From the dawn of civilization, ink has been an indispensable tool for human expression and communication. It has served as a bridge between generations, allowing us to share knowledge, culture, and stories across time and space. The earliest known inks, dating back thousands of years, were created from natural materials like soot, charcoal, and plant extracts. These primitive concoctions were the foundation upon which the art and science of ink making were built. These rudimentary inks allowed our ancestors to record their thoughts, beliefs, and histories on papyrus, parchment, and cave walls, preserving their legacy for future generations. The marks they made were more than just symbols. They were a testament to human ingenuity and the desire to communicate, leaving an enduring legacy for future generations. These ancient documents have survived the ravages of time, offering us a glimpse into the lives and minds of those who came before us. The invention of the printing press in the 15th century marked a turning point in the history of ink. This revolutionary technology democratized knowledge, making books and other printed materials accessible to a broad audience. The mass production of books and other printed materials created an unprecedented demand for ink, spurring innovation and refinement in ink-making techniques. The quality and consistency of ink improved, enabling the spread of ideas and information on a scale never before seen, leading to significant advancements in ink-making techniques. Artisans and scientists alike experimented with new formulas and methods, pushing the boundaries of what ink could achieve. No longer confined to monasteries and scriptoria, ink became an industrial commodity, its production scaling up to meet the needs of a rapidly changing world. Factories dedicated to ink production sprang up, employing new technologies to keep pace with demand, its production scaling up to meet the needs of a rapidly changing world. The Industrial Revolution further accelerated this process, with large-scale production facilities churning out ink in vast quantities. Today, ink continues to play a vital role in our daily lives. It is an essential component in countless applications, from printing and packaging to art and design. From the newspapers we read to the books we cherish, ink is woven into the fabric of our everyday experiences. It is the medium through which we access information, entertainment, and education. From the packaging that surrounds us to the art that inspires us, ink is an omnipresent part of our visual landscape. It adds color and texture to our world, enhancing the aesthetic appeal of everything it touches. Ink is an omnipresent part of our visual landscape. Its versatility and adaptability have ensured its continued relevance in an ever-evolving world. The manufacturing of ink has evolved into a sophisticated science involving a complex interplay of chemistry, physics, and engineering. Modern ink production is a testament to human ingenuity and the relentless pursuit of perfection, involving a complex interplay of chemistry, physics, and engineering. Researchers and engineers work tirelessly to develop new formulations that meet the demands of various industries, from printing to electronics. Yet, despite the technological advancements, the essence of ink making remains the same: to create a medium that captures and conveys the nuances of human thought and creativity. The fundamental principles of ink making have endured, even as the methods and materials have evolved, to create a medium that captures and conveys the nuances of human thought and creativity. Whether in the hands of a calligrapher or an artist, ink continues to be a powerful tool for expression, bridging the gap between the past and the present, and inspiring future generations. At the heart of every ink lie pigments and dyes, the substances responsible for imparting color. These tiny particles and molecules are the essence of what makes ink so vibrant and versatile. Pigments and dyes are the building blocks of color in the world of inks. Pigments are insoluble particles that remain suspended in the ink, giving it a rich, opaque quality. They are like tiny, colorful rocks that float within the liquid, creating a solid layer of color when applied. On the other hand, dyes are soluble colorants that dissolve completely in the ink. Unlike pigments, dyes blend seamlessly with the liquid, resulting in a transparent and vibrant hue. This fundamental difference between pigments and dyes is what gives each their unique properties and applications. The choice between pigments and dyes, or a combination of both, depends on the desired properties of the final ink product. For instance, if an ink needs to be highly durable and resistant to fading, pigments are often the preferred choice. Pigments, known for their opacity and light fastness, are ideal for applications where durability and resistance to fading are paramount. They are commonly used in products that need to withstand the elements, such as outdoor signage and artists' paints. From the vibrant hues of artists' paints to the bold colors of outdoor signage, pigments provide long-lasting color that can withstand the test of time. They are the go-to choice for applications where longevity and color stability are crucial. Common pigments include carbon black, titanium dioxide, and various metal oxides. Each of these pigments offers a unique shade and intensity, allowing for a wide range of color possibilities. Carbon black, for example, is used to create deep, rich blacks, while titanium dioxide is known for its brilliant whites. Metal oxides, on the other hand, can produce a variety of colors depending on their composition. These pigments are essential in creating the diverse palette of colors available in the world of inks. Dyes, on the other hand, excel at producing bright and intense colors with excellent transparency. They are often used in inks for printing on porous substrates like paper, where their ability to penetrate the surface results in vivid and sharp images. The transparency of dyes allows for the creation of intricate and detailed prints, making them ideal for high-resolution printing applications. However, dyes are generally less light-fast than pigments, making them more susceptible to fading over time. This means that while dyes can produce stunningly bright and clear images, they may not be the best choice for applications where long-term exposure to light is expected. Selecting the right pigments and dyes is crucial for achieving the desired color characteristics of the ink. Factors such as hue, saturation, light fastness, and compatibility with other ink ingredients must be carefully considered. This selection process often involves extensive testing and experimentation to ensure that the final ink meets the specific requirements of its intended application. Scientists and technicians work meticulously in laboratories, testing different combinations and formulations to achieve the perfect balance of color and performance. The world of pigments and dyes is vast and complex, with each type offering its own set of advantages and challenges. Understanding the properties and behaviors of these colorants is essential for anyone involved in the creation and application of inks. Whether it's for creating a masterpiece on canvas, printing a vibrant poster, or producing durable outdoor signage, the right choice of pigments and dyes can make all the difference. The soul of color lies in these tiny particles and molecules, each contributing to the beauty and functionality of the final ink product. This intricate dance of science and art ensures that the colors we see in our everyday lives are as vivid, durable, and impactful as possible. The journey from raw pigment to finished ink is a testament to the power of color and the endless possibilities it holds. While pigments and dyes provide color, it is the solvents and resins that give ink its structure and flow. These components are the backbone of any ink formulation, ensuring that the ink not only looks good but also performs well under various conditions. Solvents act as carriers for the colorants, allowing them to be evenly distributed and applied to a surface. They play a crucial role in determining the drying time of the ink, which can vary significantly depending on the solvent used. For instance, fast-drying solvents are essential for high-speed printing processes, while slower-drying solvents might be preferred for applications requiring more open time. They determine the viscosity of the ink, influencing how easily it flows from a pen, spreads on a printing plate, or adheres to a substrate. Viscosity is a critical factor in the performance of the ink, affecting everything from the ease of application to the final appearance of the printed material. A well-balanced viscosity ensures that the ink can be applied smoothly and consistently, without clogging the printing equipment or causing smudges. The choice of solvent depends largely on the type of ink and its intended use. For example, inks used in packaging must be quick-drying and resistant to various environmental factors, while those used in fine art might prioritize color vibrancy and longevity. The solvent must be compatible with the other components of the ink, ensuring that the final product meets the desired specifications. Water-based inks, commonly used in writing instruments and inkjet printers, employ water as the primary solvent. These inks are favored for their ease of use and minimal environmental impact. They are also less likely to cause health issues, making them a popular choice for everyday applications. However, they may not be suitable for all types of printing, particularly those requiring high durability and water resistance. These inks are known for their low odor, quick drying time, and environmental friendliness. They are often used in applications where safety and sustainability are paramount, such as in schools and offices. The quick drying time of water-based inks also makes them ideal for high-speed printing processes, reducing the risk of smudging and ensuring a clean professional finish. Solvent-based inks, on the other hand, utilize organic solvents like alcohols, ketones, or esters. These inks are known for their excellent adhesion properties and durability, making them suitable for a wide range of industrial applications. They can be used on non-porous surfaces such as plastics, metals, and glass, where water-based inks would not adhere properly. They offer superior water resistance and adhesion, making them suitable for printing on non-porous surfaces like plastics and metals. This makes them ideal for applications where the printed material will be exposed to harsh conditions, such as outdoor signage or product labels. The durability of solvent-based inks ensures that the printed material remains legible and vibrant, even after prolonged exposure to the elements. Resins, the unsung heroes of ink formulation, play a crucial role in binding the pigments and dyes to the substrate, ensuring that the ink adheres properly and resists smudging or rubbing off. They provide the necessary film-forming properties that give the ink its final appearance and performance characteristics. Without resins, the ink would not be able to form a cohesive film on the substrate, leading to poor adhesion and durability. They also contribute to the gloss, durability, and water resistance of the dried ink film. The type of resin used can significantly impact the final properties of the ink, with some resins providing a high gloss finish while others offer a more matte appearance. The durability of the ink is also enhanced by the resin, ensuring that the printed material can withstand handling and environmental exposure without degrading. Natural resins such as rosin and shellac have been used for centuries, while synthetic resins like acrylics and polyurethanes offer enhanced performance characteristics. Synthetic resins can be engineered to provide specific properties such as increased flexibility, hardness, or chemical resistance, making them suitable for a wide range of applications. The choice between natural and synthetic resins depends on the desired properties of the final ink product and the specific requirements of the application. The selection of solvents and resins requires a deep understanding of their chemical properties and how they interact with the pigments, dyes, and the intended printing surface. This knowledge is essential for formulating an ink that meets the desired performance criteria, whether it be for high-speed printing, fine art, or industrial applications. The chemist must carefully balance the various components to achieve the optimal combination of flow, drying time, adhesion, and durability. Achieving the right balance is essential for creating an ink that flows smoothly, dries evenly, and adheres firmly, all while preserving the vibrancy and longevity of the color. The final ink product must undergo rigorous testing to ensure that it meets the required standards for quality and performance. This includes tests for color consistency, drying time, adhesion, and resistance to various environmental factors. Only after passing these tests can the ink be deemed ready for use in its intended application. Transforming raw materials into a homogeneous and high-quality ink is a meticulous process that involves precise mixing and milling. This stage is critical for ensuring that the pigments and dyes are evenly dispersed throughout the ink vehicle, resulting in consistent color strength and a smooth, uniform texture. Mixing typically begins by combining the pigments or dyes with a portion of the solvent and resin mixture. This pre-mixing step helps to wet the pigment particles and prevent them from clumping together. High-speed mixers or agitators are employed to create a vortex, ensuring that all ingredients are thoroughly combined. However, simple mixing is often insufficient to achieve the desired level of dispersion, especially for pigments, which tend to agglomerate. This is where milling comes into play. Milling involves passing the ink mixture through a series of rollers or beads that grind and disperse the pigment particles into finer and more uniform sizes. The degree of milling is crucial for determining the final properties of the ink. Insufficient milling can lead to uneven color, poor gloss, and sedimentation, while excessive milling can reduce the color strength and increase the viscosity of the ink, making it harder to work with.